All right. Good morning, good evening, good afternoon, and good night, depending on where you are coming to us today in the world. Welcome to the first module of our short course, Introduction to IT. This course is designed to give people who are considering a move into the IT industry or who are curious about it a bit of a picture, a bit of an overview of what an IT career might look like in a couple of different kind of aspects. Hosted, of course, by IT Masters and Telstra University. My name's Jack. I will be your MC for the evening, and we are joined by Lily, who's going to be doing some kind of back end and behind the scenes work, making sure everything runs very smoothly from IT Masters, and Tim Jones, who is our illustrious presenter for the evening. Tim is an enterprise architect, a graduate of and mentor with IT Masters and CSU, and teaches a variety of subjects around cloud computing and its various applications, and a couple of other things with ITM and CSU. Just a bit of housekeeping for the beginning. Feel free to chat with other participants in the chat section of your Zoom. So that's down the bottom. For those of you who've responded that they are a tech troglodyte and don't know what a computer is, that is down the bottom of your Zoom window. There is a options bar. You can navigate to chat or to Q&A. If we can keep the Q&A section to direct questions about the content of the webinar directed to Tim, we will go through and we'll answer those questions at a couple of different points throughout the webinar, as well as potentially having some discussion towards the end if we have some time. And keep chats and comments and things directed to the host, panelists, or other members of the webinar cohort, I guess, in the chat section. Just before we officially begin, also, I'd like to acknowledge that we are coming to you today from the lands of the Wurundjeri people of the Kulin Nation, and pay respect to their elders and ancestors, acknowledging their sovereignty over the lands and waters and ongoing connection to their culture. Always was and always will be Aboriginal land. And officially welcome to the IT Masters Intro to Technology short course. The first module that we will be exploring tonight is a day in the life of IT. And I'm just going to close this poll that we have up now. Apologies if you didn't manage to answer it, but I think that we will all survive. It looks like we've got a majority of people who are not lying when they say on their resume that they are experienced in Microsoft Office Suite. A couple of people who can function pretty decently in the modern world, and maybe some Candy Crush champions. Several potential, we've got one potential fifth grader or fifth grade level coder, and a couple of people who are either potentially IT professionals or very IT savvy, literally computers, or having a laugh. And a couple of people who are not quite sure what a computer is as well. So we've got a bit of a broad spread of people in their levels of IT experience. To the person in the chat who's wondering if their camera is on, it is not. But I would like to invite Tim to turn on your camera and we can get started. Welcome, everybody. Thanks, Tim.
Thanks very much, Jack. Thanks for the wonderful introduction, and welcome everyone to this short course from IT Masters and Charles Sturt, where we're discussing some of the basics of IT. But the idea of this is to be a soft entry into the field of information technology or technology-based business within, in particular, looking at enterprise organizations. And we'll go through some various things around the history of where we, how we got here from what type of things there were in the past, but also looking at how careers in technology and IT in particular have grown over the years as well. Now, as Jack said, more than open to questions that you may have. So if something that I go through triggers a question, please pop it into the question and answer, and we'll be answering some questions as we go throughout the course today, and we'll be answering other pertinent questions at the end. So there'll be plenty of time for questions, so you can put them in at any time, and we'll keep track of ones to answer as we go as well. So to start with, this is what we'll be covering today. Now, next week's class, we'll be going into a little bit more information about the actual technology points. All right, so delving into a little bit more detail around what things look like. But to start with, a little bit about me. I've got over 30 years in the IT industry. I've had a whole heap of roles, and I'm currently working as what's termed as a global enterprise architect. I work as a mentor with Charles Sturt IT Masters, and I'm also working as a certified instructor for AWS, Microsoft, and TOGAF. All right, so I've got a fair bit of experience both across the delivery of IT projects, but also in the education side of it as well. Now, to begin with, one of the things which I think is valuable is to sort of understand how we got here, why it is that computers are important for the modern world, and their pertinence and the interest people had in being able to calculate things for time immemorial. So first of all, one of the first things that was available to people was what we would term as ancient computers, the ability to basically work something out on a regular basis using monoliths or large buildings that were set on particular directions based upon north-south, or being able to, in many cases, do things like detect when the spring or autumn equinoxes occurred to help with the planting of crops, etc. All right, so what all of these have in common is that they are able to work with the heavens, so stars or the sun, etc., to be able to give an idea of when particular dates occur, or being able to line up with certain things that are happening. All right, so the ones that we have here are Stonehenge. We've got the pyramids of Giza. We've got Machu Picchu and Chichen Itza that are in South America. Right, so all of these have some level in their design that's based around essentially the heavens, and being able to utilize them to be able to tell people something about the timing or other information. All right, so going back millennia, people understood the reasoning and meaning behind when certain events occurred, and they wanted to be able to gather all of that in time. So moving slightly more modern, we had mechanical computers become available. All right, so the one on the left-hand side is the Antikythera mechanism. So this one was found in a Greek shipwreck. So I think it's dated to like the 5th century BC, something like that. And this again was a tool for being able to measure the heavens. All right, so this was quite a complex tool. People have been able to go through and use X-ray tomography on it to work out the different bits and pieces in it and how it operated. But again, it was something that allowed people to work out answers to what was important. All right, so we also had devices like this in ancient China that were used again for being able to measure the stars, the heavens, the sun, the moon, etc., to be able to give answers to people around what's important to them at the time. And again, a lot of these civilizations were agrarian based. So being able to work out when plantings were required, when you needed to collect your crops, etc., incredibly important to these civilizations. So a lot of information, a lot of religion and other things tied into that requirement for them around how they collected their crops. We can also see on here an abacus. So I'm sure that everyone's had a play around with this in primary school. All right. So this is quite, once you learn how to use it well, it's quite a complex tool to be able to do addition, multiplication, and being able to add quite quickly. And if you've ever seen a user of the device that really knows how to use it, it's quite a sight to behold. Right? So someone can utilize these extremely quickly to work out sums that would otherwise be quite difficult. And the final one as far as mechanical computers go, my father was a builder. So he needed to do quotes all the time for structural work that needed to be done, and he needed to add things up before we had laptops and computers in the home and things like that. Right? So so we actually had one of these physical adding machines sitting in our home with a little roll of paper where you punch things in, and it operated through basically just using gears and the mechanisms inside the device to be able to do addition, subtractions, multiplication, etc. All right, so this is recent history that we've had mechanical computers, and you would see these sort of devices in the offices of enterprises going back only 50, 60 years. All right, so and as someone said in the chat, being able to use a slide rule is a mark of an educated human. That wasn't something that I learned in school, but it's certainly something that was utilized to be able to work out sums in a very fast manner before the advent of modern computers and calculators. Right, so we move on from there into the idea of analog computers, and what we use these for is being able to do more sophisticated work with them. The device on the left is the ACAT1, and so this was a device that was used for doing essentially differential equations, some complicated maths, but this wasn't a computer in the way that we know it. You didn't go through and input ones and zeros or punch cards or anything like that. It utilized analog, or what we mean is variable inputs to be able to work out answers. So it was much more an electronic version of one of those adding machines that we saw earlier, rather than a digital computer, which we use actual programs or the ability to build something larger and general purpose out of how it's used. The one on the right-hand side is the Norden bomb sight. So this was something that was used in World War II to help them drop bombs across Europe. And this was used to let them know when they were over the target, and you inputted wind speed and other information into there and help them with the designation of targets across the area. All right, so there's other examples of mechanical computers, such as the Babbage machine and some other bits and pieces. But this is essentially the idea of how a lot of stuff was worked out again before we had modern transistors and the capability to work through the in general purpose computing capability. Now, the final one of things looking through of before we had transistors, before we had modern computers, calculators, etc., was human computers. All right, so the women and some men that were part of the team working in particular at places like NASA were doing quite difficult computations and working things out. So they had humans doing rapid fire computations to work out things like how you get into orbit, basically dealing with rocketry and orbital mechanics and things like that. You had to have someone go away and work out the sums. So this became incredibly important, especially when you started to have humans in orbit and you needed to work out how to bring them safely back home again. All of these people were there to assist how that was. And as someone says in the chat, the movie Hidden Figures is a quite good movie that goes into the actual back history of this as well. All right, so there's so especially with the women and women of color working their way up in the world of computation in the way that we actually put people into space. All right. So just a quick pause there. Any questions at this point, or any comments from you, Jack?
No, other than great movie, love the reference. There are no current questions in the chat, so please continue on. And everybody else, feel free to enjoy the option of popping questions about the content in the Q&A section. Feel free also to have a chat amongst yourself in the future if anything comes up after this at learn.itmasters.edu.au, where you can find all of the materials and recordings from the webinar.
Thanks very much, Jack. All right, so as someone mentioned, someone mentioned no love for ENIAC. So ENIAC was one of the very early computers, the general purpose systems that was built, and one of the first people to really develop computer science within the whole world that worked on the space was someone called Dr. Grace Hopper. All right, and she was very much built a lot of the capability that we have as far as modern computer science goes. She was the first one to come up with the concepts of bugs in a computer program, because as you can see on the left-hand side here in her actual logbook, she'd put down that there was a physical moth in the machine which had caused a breakage in the program. All right, so if you ever hear bugs in a program, it originally came about from Grace Hopper and the physical insect that was crawling through the works of the machine. All right, so in the days of ENIAC, as someone mentioned, and the very early computers, they utilized vacuum tubes. So these were large structures about the size of a small light globe that would be used as a single gate. So these days we've got billions of circuits that's on a single silicon chip. So sitting inside your phone is billions of circuits. All right. So, and we had something about the size of a light globe that was one single circuit. So if you can imagine the size of equipment that you would need to create a very, very simple computer and the cost and effort involved in managing that, it was incredibly difficult. All right, so Dr. Grace Hopper worked in the very early stages of the development of computer science, came up with a lot of the precepts around it, and invented the programming language of COBOL, which is still used today, is a big part of mainframe computer systems. And she ended her career in the Navy as a Rear Admiral. So I'm not sure exactly how you would introduce her on stage, whether it would be Dr. Rear Admiral Grace Hopper or Rear Admiral Dr. I'm not sure, but she was a very impressive person. All right, and so she stayed through her entire career and continued through her Navy career to continue to make great strides in the world of computer science. So the world sort of continued to progress with computer science, with university degrees first starting in 1953. So the first one was in Cambridge in England, and they had their own computer on site that allowed them to go through and develop it. It then essentially exploded, especially in the very large universities through the 60s and 70s, and became a standard part of how we saw universities and the career capabilities of people grow through all of that period, especially as the number of computers continued to grow at the same time. So there was a famous quote by someone from Silicon Valley that thought that there would never be a need for more than a handful of computers worldwide, because they were used very specifically for doing large-scale things. One of the very earliest computers in 1950 was sold to manage the 1950 census. It was that sort of thing within the US, where they looked at using computers and they thought they were too expensive, too large, and too cumbersome to be used for everyday activities. But as we saw, the requirements of computers and businesses continue to expand as essentially computers became cheaper and more capable over time. All right, so we have a thing which has helped not only provide some background to how we got here, but has also helped drive the advent of further computing technology over time, which is called Moore's Law. All right, so one of the early founders of Intel was called Gordon Moore. He came up with the idea that once every 2 years, that the capacity or number of transistors on a chip would go and double, basically, that you could have within a certain space. That was then shortened a little bit later to once every 18 months. And that ended up being quite a good sort of guess as to how things would go. But it also gave a trajectory for the businesses to aim for, so that they could actually plan to build their systems based upon that exponential growth. And it's something that we've seen continue over the years as well. So we've still got Moore's Law of being able to double the capability of computer chips has managed to continue doubling all the way from the 1960s up to the present day. All right, so we had, through the 70s, we had a rise of general purpose computers, and we had a whole bunch of systems that went into large businesses, then medium-sized businesses, and then relatively small businesses through the 70s. Right? When the 80s came around, we had the advent of personal computers being ubiquitous. Right? So they became available everywhere. People had them in their homes, and they became commonplace in many businesses as well. So things moved from everyone having a ledger and a calculator on their desk in the late 70s through till by the mid-90s, there wasn't an enterprise that didn't have computers on most people's desks within any large company through the world. It was through that period that we really saw ever enlarging careers within the IT and technology space. So it was 1990 when I entered the IT arena, and I saw massive changes through the 1990s as things moved from a large business having mini computers or mid-range computers and 1 or 2 personal computers for being able to do certain aspects of work, to them being essentially everywhere in the advent of the internet age by the end of the 1990s. Right, so it was through this period that we ended up with a normalization of different career options that people had. Right, so again, part of this was normalized by people like Dr. Grace Hopper, and the ideas behind how you put together a solution for business problems using technology became sort of normalized around how you would build things. It would be in the 1970s and 80s, you had roles such as systems analysts and programmers, and you had the people who would do the operations work on their computers. By the 1990s, that had changed around slightly to systems analysts had moved into being different types of architects, infrastructure architects, technical architects, solution architects, enterprise architects. You had development staff, which has moved from being normal programmers to being front-end developers, back-end developers, from being HTML developers, web developers, and a whole range of other things. You have the support personnel that keep all of the computers and programmers running, and you have system engineering as well, the people who implement new technology, who start up new programs and make them available. All right. The other side of this, so I've spoken a fair bit about the IT side, but a big movement that we're seeing at the moment is the move of technology into the normal business side. That in the past, we would have IT and we'd have the business would ask IT to do some work for them, and they would then go away and build the technology piece, and the business would then use that. With the advent of new platforms and capabilities, we're starting to see business people become technology experts, because tools such as Salesforce or other tools that are utilized by the business require a deep technical knowledge around how to utilize them, how to get the best out of them. And so we see technology people not coming from the IT field, but coming from the business side of the organization as well. So it means that there's more options for someone with a technology mind to get a role or find something that interests them. So one thing that I wanted to talk about, just to give an indication of what things look like, is my career path, essentially. All right, so just to as a statement at the start, one of the things I want to say is that my career path is not something that's available to people now. The accessibility or ability to enter the workforce is both easier and harder in different ways than it was when I joined, and there's also a lot more competition for roles that are around there. But I started off as a computer operator working for a market research company where we had mid-range computers. So if anyone's ever seen any of those old movies where you have reel-to-reel tapes that basically copy data backwards and forwards, it was my job to carry those around and mount them and make systems run for pulling those sort of things out. Now, that sort of work was not only required some technical knowledge, but it was also kind of physical. I needed to carry around a whole bunch of those tapes. Each one of those could carry a couple of megabytes of data, which is thousands of times less than what you can carry around in your pocket on your phone right now. I then moved into programming for a small period of time. I then worked doing mobile fixing of computers, worked into working for a large corporate organization as a desktop support person, into working as a systems analyst for their applications that they had within there, and then worked my way into the architecture field. And since then, I've worked across multiple different types of roles, either working for vendors or consulting or for corporate entities, but I've had some form of architecture or the requirement to talk about technology, understand technology, and being able to basically show a big picture around how different things hang together. So that's led me through multiple different iterations and many different roles through to my current place, where I'm an enterprise architect working for Dell Technologies. And my specialization where I work is across multiple telecommunications companies, because things are changing within telecommunications as well, in that IT technology is becoming commonplace within the world of telecommunications. It has for a very long time, but the technology is getting much more aligned with the capabilities that we have within IT. And we're seeing some of those themes, such as things that you might have heard of, which is cloud and containers and automation, starting to come into that telecommunication space along the lines of what's happening with 5G and other supporting technologies at the same time. All right, so that's my sort of career in a nutshell. And that leads us into some talk around what business systems look like now. So just a quick check-in with you, Jack. I don't think that we've got any questions still, do we?
We don't. Just a quick reminder to keep comments and messages to general participants to the chat section, and questions for Tim about the content of the webinar to the Q&A section. That's all.
Yep. And as someone mentioned, they said in the chat, JB Watson was VP at the time, who estimated the world market for computers to be 5, which is pretty funny. So so thank you for that, Ray. Okay, so here we move into enterprise computer systems. Now, when we're talking about enterprise computer systems, these are different from what we have within either small business or home office type organizations. Within many small businesses or home office or home use, we utilize laptops or desktop PCs and the ability to run programs within our own individual space. All right, so we've got our own laptop. When I'm running this webinar off at the moment, allows me to run this program and multiple other ones. Now, when you're dealing with an enterprise, a large business, there's a large scale difference with how they need to operate their systems, their programs, etc. All right. What we see is the enterprise systems have a requirement to run many programs utilized by potentially thousands of people. Now, this requires not only larger scale systems to run complex programs, but also requires systems that can manage a scale to be able to support those thousands of users. So for a single application, we might have many physical servers sitting within a data center that run the actual individual application that business users need to actually do their job. Now, we call this a data center, and a large scale business will have multiple of these. Right now, one of the things that we're seeing is a move towards things moving to the cloud at the same time. So people might have heard of the cloud. To be clear, the cloud is just another data center. We'll go into that a little bit more a little later, but when we talk about companies like AWS, Azure, Google Cloud, whether we're talking about cloud storage on your iPhone or other cloud-based applications, any of those systems, all of those systems are running in a data center that look like what we can see on the screen at the moment. Right? So there's multiple aisles of computers that are sitting within racks, and we manage how people can get access to that site. And again, large-scale companies have multiple of these places. So a company that's as big as one of the large banks in Australia would have 2 or more large data centers, as well as other smaller ones or connections to cloud computing sites. Now, for looking at data centers, we have some key terms. All right, so first of all, we have data center. All right, so the data center, again, is the beating heart of the IT within the organization. Now, this used to host all of the large-scale applications that were around like 10 years ago or so ago. All right, so we'll go again in a couple of minutes into talking about cloud and how things have moved towards that. But organizations still utilize data centers. All right, so they still have applications sitting in them. They're still an important part of many organizations, and it's still important to understand how the technology works, because it's how things work in the cloud world as well. You have to understand what's happening under the hood if you want to understand how an application is running. Now, we have our data center, which is our beating heart of the organization from a technology perspective, especially 10 years ago, and in many cases, still the case now. We have compute or computer systems. All right, so this is what actually does the work. This is the workhorse that has a central processing unit. And within an enterprise data center, the computers don't look like your laptop. What they look like is a flat pizza box that is screwed into a basically a closet of 4 steel rails. All right, so it has some disk drives that sit on the front and some flashing lights, and it has some fans on the back and power cords, right, and connections into networking and things like that. But that compute piece is what actually runs all of the programs. We also have storage. So this is what holds all of our programs or all of the data which is used by the users. So this might be sitting alongside the compute. It might be some disk drives that are sitting within the computer, or there might be a different type of system which is sitting separate, which can be what we term as a storage area network, or or network attached storage, or other options for how we can make storage available for a large number of users. There's also some type of networking which connects all of these computers together, because if we've got a computer sitting within the data center, we need a way for people to be able to access the resources on that computer. So networking provides us the capability to link in to that system and allow us to gain access to it, and for the other computer systems to be able to all talk with each other. One of the other things that we have is a hot and cold aisle. If we go back to the picture we can see here, we can see a whole bunch of cables that are sitting here. It used to be that you would cool the entirety of a data center, and the computers would pull in air from the surrounds and just blow it out. And that worked fine. But as these data centers grew, the idea and management of these systems also grew. What we can see here, we can see a bunch of cables sticking out of these systems. So this looks like the backside of those computers. So they would suck air in from the front of the computer, pull it over all of their hot innards, because the computers, if they're being used a lot, they generate a lot of heat, and blow the hot air into the center aisle that we can see here, where this person's about to walk down. And what this means is that we can capture all of that hot air and vent it out, and we can blow cold air directly onto the front of the systems. So when we're looking at computers in a data center, we have the idea of hot and cold aisle within the environment. And as part of that as well, we also have CRACs, or cooling, which is computer room air conditioning. And so this is, you can't operate a modern computer room without it, because the computers themselves will literally cook themselves. There's a operating temperature for computers, and even the most hardened ones require a temperature, an operating temperature of under 65 degrees. If you have a computer that's running quite powerfully and sitting within a sealed box, it'll very quickly rise to a temperature well above that. So, so you need to have cooling and the capability to cool down your systems overall. So I mentioned that we would have a quick discussion about cloud. Now, again, it is someone else's data center, right? So, so it's not mysterious. Again, if you went into the data center for AWS or Azure or Google, it would still look very similar to this. It wouldn't be much different to anything else, anyone else's data center as far as the way it looks. It'd be large scale and it would be quite homogeneous, but it wouldn't be much different from this sort of view, right? So just to dispel some of the mystery around cloud computing, right? So it is just someone else's data center. Now, the reason why it's valuable is, one, because the management of data centers is quite expensive, right? So if you are utilizing a data center, you not only need to provide the equipment, you need to provide that networking, the compute, the storage. You need to make sure that there is enough power, which can be quite a significant constraint. I've worked with many clients where they physically could not add more computers to their data center, even though they had space, because they could not get more power from the power grid, right? The electric lines that were coming into their local area couldn't supply enough electricity to allow them to expand their data center, right? You need, again, that valuable real estate, and you need to manage it as well. So you need to manage all of those things. You need to not only manage the growth of your environment, but also the changeover of your systems. Every 3 to 5 years, all of those compute, storage, or networking components usually need to be swapped out for more modern ones. Now, if you're dealing with a complex application, in the past, that was incredibly difficult. You needed to go through a large-scale change and project to do things. So by the time your application actually went live, it might be not very long until you actually need to replace the underlying equipment that relies upon it. All right. So there's some advantage for a lot of businesses in moving their systems to the cloud, because they don't need to manage those sort of things anymore. What it also allows is you can have a pay-per-use, rather than if you put something into your own data center and you have one really busy time once a month when end of month reporting goes. And for a 2-hour period, you need a computer that runs at 100% utilization, and the rest of the month it sits at 5% utilization. Now, you've got quite a waste of computer power sitting there, not being used for all of that time. Now, what does that mean? It means that you need to pay for the maximum that you need to be there all of the time, rather than being able to scale up or scale down your environment in a live sort of basis. Now, using cloud technology and what's offered by those cloud providers, you can save money in that way. Other key parts of the cloud environment is automation through APIs, or application programming languages, programming interfaces. We also have the ability to have automation around how we deploy all of these systems and manage that scale up and scale out sort of manner. Now, as what I see a lot of customers do is part of them moving to the cloud, that things like everything in the world go in cycles. There's been moves of CIOs, which it will go into in a moment, the people who manage the strategy for large organizations of how they deliver technology to their clients, the business within their enterprise corporation. And the part of that movement has been to move many things to the cloud. And in some businesses, this can be very advantageous, but in some cases, they pick up components of their application space, those things that are sitting within the data center, move them to the cloud without any form of transformation or utilization of the automation or other benefits that you get out of the cloud space. And you end up with the same problems that you had before, but rather than it costing you a fixed cost every 3 years plus the ongoing management of it, you're now paying on a monthly basis for the same sort of capability. And so we see some customers have made mistakes with the resources that they choose to push out to the cloud, and some of that changes backwards and forwards. Right. So for cloud, there's a few different types of cloud offerings. So all of these things have some form of automation and the ability to build them on the fly and pay-per-use as part of them. So first of all, we've got infrastructure as a service, or what we would call IaaS. We've got platform as a service. So first of all, infrastructure as a service is where you're basically purchasing a computer. That compute portion that we were talking about earlier, the idea of essentially a system, a laptop sitting in the cloud or a computer sitting in the cloud that you can run some workload on. And that can take many different forms, but basically the ability to run things. Now, the important thing here is that you've essentially got that infrastructure, that computer piece sitting there allowing you to run it, and you still need to manage things like the operating system, Microsoft Windows, or what have you, and the applications that are sitting on top of your system. Platform as a service is where all of those things about the operating system and backups and ongoing management are taken out of your hands, and a platform is offered to you from the vendor. So in this case, this is often things like database servers. So database services are a great example of this because they can be complex to manage, and we require expensive people to help manage that sort of system. And platform as a service can mean that you can have an environment up and running really quickly with a robust ability to keep track of all of your data and things like that within your application. We then have software as a service, which again is another key way which businesses are moving towards. And many businesses have a preference towards moving towards software as a service rather than managing their own systems. What this means is, instead of having your own infrastructure or having your computer systems with programs loaded on them in the cloud, what we have is the software is available through a website, and we have again APIs, or those application programming interfaces, the ability to interface with the application, but we don't need to manage any of the components of it. A key example of this, many of you will have heard of something like Salesforce, and building skills in that sort of area is one of those things that I was talking about earlier, where there's a technology requirement around being able to deliver that sort of capability within the business, which is separate from IT, but is definitely a technology-based career option. And then you might see something like XaaS, or anything as a service. And what this is talking about is there's many different other types of as a service offerings that can be available through the cloud providers or from individual companies that are offering individual systems. So we have businesses that have grown up for providing databases, storage, and other components, but anything that you can think of from the IT world can be offered as a service. And what this means is that there's some level of automation or ability to script or manage through programmatic means for the platform, and that you're usually paying for it on a monthly basis rather than a capital outlay. All right. Now, I think, Jack, we've got some questions now, is it?
We do. So the first one is more career-based, and Ankita has asked, with this knowledge of cloud computing, is it possible to return to the IT field after a 9-year gap?
Yeah. So absolutely. And there's definitely a change in the structures of IT after a 9-year gap. But a lot of the key components within IT are as valid today as they were back then. And coming back into the field after a 9-year gap, I would absolutely suggest learning something about cloud computing and how that operates. And we'll have a bit of a discussion around career paths and things like that later. But the base of that is still everything that you learned in the past. So understanding those things around compute, storage, and networking is incredibly important, and understanding how those things fit together gives you a level of understanding of cloud computing that many people coming into the field don't necessarily know. So I still get a great deal of value from the experience that I had within IT 20 or 30 years ago. So it is still incredibly valuable, but updating your skills is definitely worthwhile to make sure that not only you understand how IT is being used at the moment, but also making sure that you can be marketable to organizations that would be looking for someone as well.
Great. And, if you're looking for a bit more kind of formal and structured continued instruction on a variety of more current up-to-date topics in the IT industry, feel free to check out the other IT Masters and CSU short courses that are available online, and potentially visit our eligibility page on our website, which Lily can pop in the chat as well, to have a look at your eligibility for postgrad level study with IT Masters and CSU. We've got another couple of cloud related questions, so I'm going to roll two of them together. It's about data security. So Saladin has asked, if we assume that the outsourced data in the cloud will be under the responsibility of the hosting company, are there any international regulations in this area? And Stephen has asked, if I'm outsourcing my data center to the cloud, aren't I outsourcing my IT security to the data center operator as well? So isn't moving to the cloud more risky from an IT security perspective?
Yeah, absolutely. So the cloud service providers cover this off quite well. So there's what they term of, if you go onto the AWS website, there's what's called a shared responsibility model for security. So they basically map out what's our responsibility as a cloud service provider and what's your responsibility. So there's so to go back to Saladin's point, if we assume that the outsourced data will be under the responsibility of the hosting company, that's an assumption we can't make. We can't abrogate all of our responsibility as a business and make the hosting company responsible for everything, because we need to make sure that our data is secure to the level that the data is required. As an example, if we can break even though a hosting company does nothing wrong whatsoever, whether you're using AWS or Azure or some other hosting provider. If we held data in Europe and we held data in Australia, as an example, it would be technically completely fine to pass information between those two sites, technically using the cloud service provider. All right, so there's nothing wrong there. It's in line with their service requirements. However, you need to know if you have some personally identifying information that's coming from Europe, you have regulations in Europe that mean that you're not actually allowed to transport that information to outside of the European Union. And so you're actively breaking the law. And the hoster can't know what your data is or how you're using it. So they're responsible for the physical security of the data center. They provide a whole bunch of tools and capabilities and firewalls that you can utilize, but through your architecture of your cloud solutions, how you deploy them and how you manage them, you can either make them secure or you can make them insecure. So they support you in that, but they try to make it as clear as possible that they're not responsible for how you deploy your information from your organization. All right. So as an example, within Australia recently, we had a major breach of Optus that happened mid to late last year. All right. And that breach occurred because there was a training system that had credentials that were able to be utilized on a live system that allowed them to get access to the entire customer database. All right. So a cloud service provider in that situation is providing the physical security and the tools to enable you to secure your environment, but complex IT systems, you can't push off that risk of breach to another provider. You can certainly get security professionals on board to help you with that process, but cloud security is not that different to data center security. So you're still responsible for many of the same things. And in many ways, it's easier to manage those things because you have much more tools that are available at a very low cost that wouldn't be available to you in another data center. But you still need to be aware. One of the other sides on cloud security and the ability to deploy applications utilizing cloud systems is that there are statements and certifications and attestations from the cloud service providers around their adherence to certain internationally recognized regulations and standards. So you can go onto those sites and see that that their ISO 27000, for example, that they follow security standards and other bits and pieces as well. So you can be assured that that they are able to meet the requirements of being able to host things like credit card or personally identifying information within their environment for financial systems and that sort of thing. So you've got the capability again to do those things and they assist you with it, but the responsibility doesn't leave the organization just because you've moved it to the cloud.
Great, thank you very much. That's a fantastic answer. And we've got another question from Nabin, who's asked, how does the cloud provide a networking service to the client? So I assume that's about sort of networking as a service.
Yeah. So first of all, there's multiple ways that we have networking involved in a system. First of all, the simplest is some form of networking from the internet to some cloud service or capability. All right. So in that case, if you're hosting a basic website within AWS as an example, AWS will manage that networking link from the internet through to your service, and you don't need to worry about any of those sort of things. The next layer above that is to host some application or web-based systems within the cloud where you've got a network sitting within that cloud environment. And what that looks like is a virtual sort of view of networking equipment or the ability to add systems to a networking environment. We're not going into the detail. It's the other basic networking short course covers things like subnets and IP addressing and things like that if someone's interested. But we can have subnets for our applications sitting within that cloud environment, and we can also give access to the internet or to other providers as part of that. So we've got a networking service within the cloud environment then that hosts all of our different systems that can talk to each other. All right, so that's what we would term as a virtual private cloud network. So that allows basically all of our different bits and pieces to talk to each other. Next, beyond that is the ability to go through and have the cloud environment connected to our corporate or personal environment. And there's a couple of different ways to do that. We can extend our corporate network or our private network into the cloud by using a VPN, a virtual private network, that allows us to have a secure connection over the internet into the cloud environment. And that would allow us, if we had, again, that subnet, that collection of computers sitting within the cloud, we would be able to have our systems within our own network talk to those systems over that link, right, and be able to set up the networking within our environment to have them be able to talk backwards and forwards over that link as long as we had an internet connection essentially on both sides. Right. And finally, we have, again, looking at the AWS side, we have essentially what amounts to a leased line from the likes of Telstra. So we have a direct connect connection, essentially a direct link into our cloud service provider. And so this is a private line that can be as fast as we want. So we can have 10 gigabit line going into our cloud service provider that allows us to have networking information from our internal systems go backwards and forwards. All right. So there's multiple different ways that it can operate and that we can utilize networking. But again, as I mentioned before, networking is incredibly important to understand from an IT perspective if you're looking at managing IT systems. If you're looking at where I've come from, which is the IT plumbing side of the business, of being able to connect all of those systems up together.
Great, thanks very much, Tim. That's the end of the questions for now.
Awesome. Right. All right, so now just a little talk about the business structure within a corporate environment. So you can see on the screen here a view of the way many enterprise businesses are structured. Now, I mentioned this a little bit earlier around how we deal with the business from an IT side. So in a traditional business, we can see we've got the CEO, the head of the business. We've also got a CIO. So this is a chief information officer. This is usually the person responsible for setting the strategy and direction of the IT or technology systems within the organization. They're the people that are responsible for any programs that are written to manage individual systems, and they're also responsible for managing things like data centers or cloud service contracts, the ability on how you manage and migrate those things, and you update all of your compute infrastructure and make it available for people. All right. Now, some key things to understand for anyone who hasn't worked in that space. Within most organizations, the technology space within the organization is a cost center, right? And why that's important is to understand essentially where the money comes from, right? So money's important within any business, but the IT business within an organization is not something usually that makes money for a business. It's required to allow other parts of the business to make money. Like they wouldn't be able to operate without technology, but the IT section itself doesn't make money. So every 6 months or a year or however long it is that their budget cycles go through, they need to go hand in hand to as we can see on the right-hand side here, the chief financial officer or other components within the business to basically request money for any expansion or changes that need to be made. There needs to be budgeting put in place for the ongoing management of the environment, and you need to have people dealing with the projects to change and manage your overall systems as well. Now, what this means is for the entire time, 30 plus years that I've been in IT, there's been a constant push to do more with less. It's not like it's anything hugely different from what we see in any other part of business or anything else, but it's a constant within the technology space that the expectation is that the budgets for IT aren't generally growing. They're generally looking to bring them down, which is one of the big pushes of why people are moving towards cloud. Now, what we see with this is that normally we would have people like programmers, support staff, systems engineers that are working within the IT organization, are working underneath that CIO, right? We would often have within the business people such as architects would still be under that IT section, but architects are a link between technology and the business, right? So architects' roles are generally to take the requirements that come from the business, usually through roles such as business analysts, people who can understand the needs of a business and being able to communicate how those business needs need to translate into the requirements for building technology. And an architect can take that information and build a plan for delivering technology off the back of it. All right, so all of these things work together. Now, one of the key movements that I was talking about before, again, is that we're starting to see a move towards more technology people working not within the IT section, but working within the line of business. So as an example, my partner works in communication automation for a large business, basically within the marketing side of the business, but utilizing a tool such as Marketing Cloud, which again is one of those software as a service platforms to provide technology rather than it having anything really to do with IT. The money for the platform doesn't come from IT. The technology doesn't come through IT. It doesn't rely upon any IT people to deliver it, and the experts in the field are explicitly within that marketing side of the business rather than being on the technology side. And so this is becoming more and more common that significant roles for technology are broadening. All right, so again, like everyone, you need to do more with less, and we're seeing the same in those marketing and corporate communications type fields. And what this means is that there's other avenues that are becoming available, all right, for jobs, for roles that we'll go into in a minute. Now, what this can mean is that roles that didn't exist only 8 years ago now exist. So my partner's title is marketing automation manager. All right, so that's something that absolutely no one had ever heard of, like 8-9 years ago or something like that, or at least not admit to. Right, so she hires a bunch of people who are technology experts in the marketing cloud type space, and we're seeing a growth in the need for those types of experts and capabilities. So a career in technology now, just over the last few years, doesn't necessarily mean a role within the IT part of the business. Right? It's possible to either come in as an expert in a particular tool, or to grow from being a process-orientated person within a business and move into a technology field within there. All right. So that's my little talk about Business 101. Now, Jack, I think we've got a few more questions.
We do. So I'm going to start with this one really, really quickly because Ali has asked which is a better career path, cloud transformation or cloud architecture. I'm going to say I think personally that's a question that only you can answer, Ali, because that's very subjective, and a lot of the factors that go into that are going to be personal to you and what you are going to enjoy and be good at, and be engaged with on an ongoing basis in a way that you can grow your skills, as well as what opportunities are available to you personally at this time. But Tim, do you have any thoughts on which is a better career path?
Oh, look, absolutely. Just to back up what you're saying as well, Jack, that the whole reason I got into IT in the first place is it was something that I was passionate about, right? And it meant that I went to work, I did my work, and then I took thick manuals home to read to read at home as well. It's pretty sad, but you know, like I was interested in what I was doing. I was motivated and keen, right? And that, yes, you can have a career where you just turn up and do whatever on a daily basis. And in IT, there's plenty of people that have done that. But IT in particular is such an arena which continues to transform and change over time, that if you're not interested in keeping learning, or you're not interested in understanding technology or getting to the root of it, if you're not a curious person about the sort of space, you won't do particularly well. All right, so because you need to have that level of curiosity to keep you motivated to keep learning, as well as actually doing the day-to-day functions that you train up for. Now, in regards to cloud transformation or cloud architecture, again, they're quite different skill sets. So I work currently and have worked in cloud architecture, and the skills there are around negotiation, understanding, explaining, interpersonal skills, as well as having a solid technical understanding of what's happening within the environment. Now, cloud transformation is more around having, those soft skills are still important, but you are more close to the actual technology itself. If you're looking to change or transform organizations from traditional IT to having a DevOps type model and things like that, it requires understanding of development and coding and APIs, and how you implement that technology, very specifically using cloud technology. So again, there's no better career path other than what actually suits your own personal capabilities or interest, or what's going to get you up in the morning and make you want to deal with things. If having coffees with clients to talk about long-term strategic plans is the thing that you're interested in, then that's that's my job as is chief coffee master. But if you're interested in actually getting into the nuts and bolts of delivering technology on a day-to-day basis, then we'd be looking at cloud transformation. But that's not to say that you can't do both. You can't move from one to the other, and you can have a viable career that spans multiple areas.
Thanks very much, Tim. Quick question, really quick, yes or no? Will you be covering governance concepts and disaster recovery strategies? Just going to add on to this next week.
Yeah, so covering in a short sense, so not going into any detail. So this is IT basics still, but we'll be going into a little bit more detail around the components of a data center and how to build that out. So this is the light fluffy version, and next week will be the slightly less fluffy version. But this is not at all a class which is designed to go deep into any of the subjects. So we'll be touching on those things, but not going into any design considerations or anything like that around them. So we'll be covering them off as concepts, but not as subjects.
Great, thank you. And I would add to that, Ray, if you are interested in further study on IT governance, there is an IT Masters in CSU full-length subject called Concepts in IT Governance, which may interest you in the future. And finally, this is my personal favorite question. Thank you very much, Cougs. Is the current trend to automate everything and hand it off to AI to manage an early sign that we're breaking rule number 1, i.e. don't build Skynet?
Yeah, so that's interesting. So one of the things that's come up just recently off the back of GPT. So if anyone hasn't been to the OpenAI website, absolutely sign up for it and ask it some questions, get it to write a birthday card to your partner or something like that. It's brilliant in its capability to respond to you, even in its ability to write code and automation and things like that. So it is an incredibly valuable tool, as well as some of the tools for creating AI-generated artwork and things like that. I've utilized some of that, not in the presentation tonight, but I have used in presentations AI-generated artwork because it's really easy to go and request a particular picture and you can have it sitting in front of you within a few seconds. All right, so very valuable tool. Now, OpenAI themselves, they have in place some controls around AI. So they very much built their technology around Don't Build Skynet as part of the OpenAI charter and how they're deploying their technology. But they came out with a warning this week, in particular about their competition essentially in the marketplace, that there is a whole bunch of people coming through and developing that sort of capability without the checks and balances that they have in place. So, but in regards to Don't Build Skynet, I think that it's interesting. It's an interesting concept, but it's ChatGPT and things like that are still a language model. It's even though there's that one Google engineer that thinks it's sentient, it's not really sentient. It's managing to very cleverly pretend and portray and things like that. There was someone that went through and used 6 months worth of 4chan data to train up a chatbot, and the stuff that it came back with wasn't particularly nice, but it beat a lot of the tools that basically are used to work out the Turing test, because it was able to come back with responses that seemed very human. All right, so it's possible to break things, but again, they're not actually intelligences right now. They are still very useful tools. The bigger arena for me around this type of technology and how it's going to impact us over the next 10 years is not so much around building Skynet, but what we do with the automation of a workforce. So if we end up with an automated workforce, so for example, 20% of the American workforce is driving trucks and deliveries and things like that. If we automate all of that, there's 20% of the workforce that are automatically gone. Now, this can be a massive step forward from freeing of humans, of people, of drudge work. It's one of the reasons why I'm always quite happy to use the self-scan environment within a Woolworths or anything, a supermarket, because automation means you're getting rid of the requirement for people to do really boring jobs. But the flip side of that is what happens to all of that saved money and potential profit. If that goes into the pockets of large capitalists, then it's not good for society. And so that's where I think that we're going to end up with a rocky road, because of course all of the money, while it can, is going to go into the hands of capital. But as a society, I hope over the next 10, 15 years of tumultuous change and many, not just things like driving, but many different roles, from accountants and lawyers and things like that, utilizing AI, not getting rid of the role, but being able to do a lot of the drudge work for them, will mean that those sort of workforces will basically collapse with the number of people that need to practition it. So we're up for interesting times.
Thank you so much, Tim. Getting into some pretty deep philosophical questions there. I'm just going to move on from the Q&A section at the moment, because we've only got a couple of minutes left and we've got to wrap things up. But a reminder as well that if you would like to discuss these deep, interesting IP-related philosophical questions, you're free to do so in the discussion forums at learn.itmasters.edu.au. Thank you, Tim.
Cool. And all right, so just last piece is just how to get a job in IT. All right, so the difficult one is experience is key. All right, so so it's always the trouble of what we look at with how you get into a role when you've got no experience. All right, so if you've got some related experience or some business experience or something that you can relate off, if you've worked at Harvey Norman in the computer center, that's a form of IT experience that you can utilize for moving the next rung up and getting some sort of role in technology. All right, so being able to find some sort of role which is technology adjacent or within the technology area, even if it isn't actually practicing technology, gives you the opportunity to move over to something. So the first role may not be your dream job, but getting any role would be my recommendation that you can actually get, would be the first step. Secondly, you need to be able to essentially sell yourself within the organization. So again, moving up from a related role, undergraduates or education degrees, etc., can be valuable. They're still valuable these days. So as a background, I went through and I started undergraduate studies, didn't complete them, and then I did my master's without completing a graduate degree after I had like 17 years of IT experience. I was able to utilize my experience to move into IT masters and did my studies there. All right. Nepotism is always a good way. Right? So a story for another day is I got my first role in IT partly through mistaken nepotism. Certification, I've utilized that a lot to manage my career over time, that I've grown my personal brand, my personal knowledge, and expanding into new fields like cloud and architecture, etc., through the use of certification to show that I'm ready for roles in that sort of space. Networking, this is an IP networking or technical networking. This is actually turning up to events. If you look at Meetup or sites like this, of being able to talk to people in the field, and it's ways that you can gain access to what you need to get a job, or can actually get you a job. As I got one of mine through one of the times I was going to university, met with someone that knew someone that was looking for an entry-level role at the time. And as I was mentioning before, we also have hobby interest, right? So if you're interested in the technology, if you're active in communities or areas that people are using the things, whether it's working with containers or doing 3D printing and managing STL files or anything else like that, being interested, passionate, and working again with communities can help you get a role, but also build skills in other areas. Okay, which brings us to the end, Jack.
Thank you very much, Tim. So we have actually closed the Q&A for tonight, just in order to be able to finish relatively on time. Thank you to everybody who submitted questions throughout the webinar. And we very much hope to see your continued questions and discussions at that forum that I've mentioned a couple of times, which is able to be found at learn.itmasters.edu.au. Feel free to discuss to your heart's content any and all of these questions or any others that arise from the materials. And if you'd like a refresher on those materials, you can find those within 24 hours. So the recording of this webinar, as well as quizzes and any other reading material that Tim decides to put up, also at learn.itmasters.edu.au. We've got another session of this webinar that will be happening next week, same time, same place. So that is 7:30 Australian Eastern Daylight Time. Is it still daylight time next week?
Yes.
It is. Yep. Thank you. Australian Eastern Daylight Time, 7:30 p.m. Next week, next Wednesday evening or morning, depending on where you are in the world. And that will go a little bit more into the nitty-gritty of some of the topics that we got an overview of tonight. And in the meantime, if this webinar has brought up some feelings of interest in a potential IT career, please do check out our other recorded short courses that we've previously had available, which are also available at itmasters.edu.au. Or if you're super, super keen and ready to dive into study or interested in the potential for you to do so, please visit the eligibility link, which Lily has kindly just popped in the chat section. You can put in your current experience, qualifications, knowledge levels, and get a call from a friendly IT Masters Eligibility Assessment Officer to have a chat about your options for postgraduate study, regardless of your previous level of formal study. If you've got degrees or qualifications in other areas, or if you've got industry-based certifications in IT as well, we welcome your interest in studying with us, and there are a variety of pathways into that study. Thank you very much, Tim, and thank you very much, Lily, for making sure that everything ran smoothly on the back end of this session. My name is Jack, and I have been your MC for the evening. Thank you very much for everybody who attended. Have a great good morning, afternoon, evening, or night, depending on where you are and what time it is in your location. We'll see you back here same time next week. Thanks,
Thank you,
everybody.
everyone.